Let's continue with question number 2 from the thinking question set. We have to find the values of a and b in the function f of x equals ax squared plus bx, given that f of negative 1 is 5 and the slope of the tangent at x equals 1 is 7. So a lot of information given. We're going to start writing it down step by step. First, we're going to write the equation of the function f of x equals ax squared plus bx. As you can see here, we're missing the coefficients a and b. And we're given that f of negative 1 is equal to positive 5. And what that means is that if x equals negative 1, then the value of y must be 5. So we can substitute this into the equation of the function. So f of x would be equal to 5 when x equals negative 1. So wherever we see x, we replace it by negative 1. And for f of x, we'll write 5. So we have 5 equals a minus b. As you can see, we have two variables in the same equation, which means that there will be an infinite set of numbers or values of a and b that can satisfy the equation, which means that we cannot find a and b right away. Whenever we have two variables in an equation, we need a second equation to find a single solution. So when you read the rest of the information here, we are given that the slope of the tangent at x equals 1 is 7. So we are going to have to do some translations here, if you can call them so. So slope of the tangent, in other words, means the derivative of a function. And we are measuring the slope of the tangent at 1, which means that the derivative of this function at x equals 1 must be equal to 7. So we have to start off by finding the derivative of f of x. I will rewrite the equation of f of x here. So remember that is ax squared plus bx, which means that the derivative f prime x would equal 2ax plus b. Now we're ready to use the derivative equation to substitute the numbers given. So the derivative at 1 will be 7, which means when x equals 1, then the value of f prime at 1 will be equal to 7. So this would be 7. So let's write this down. We have f prime of x equal to 7 equals 2 times a times the x value, which is equal to 1 in this case, plus b. So as you can see here, we have 7 equals 2a plus b. So now that we have two equations that connect the variables a and b, we can use both of them, so we can bring them together in a system of equations to find the respective values of a and b. So I would list the equations together. So a minus b equals 5 and 2a plus b equals 7. So it is very easy to use the elimination method in this case because, as you can see, we have the same variable with exact same coefficients but opposite in sign, which means that we can easily solve this by simply adding the two equations. And we have a plus 2a equals 3a. Negative b plus b equals 0, so b will be eliminated, and that's where the elimination method name comes from. And 7 plus 5 equals 12. So for a equals 4. And once we have the value of a, we can use either equation, the first or the second, to find the value of b. I would use the equation with the smallest coefficients, so in this case 5, but either equation should work. So with a of 4, then we would have negative b equal to 5 minus 4, 1. So b equals negative 1. So we're going to say that the values of a and b must be respectively 4 and negative 1. I hope this made sense, and thank you for learning with me. Bye for now.